Let's take a look at calculating the net force on a point charge. In this case, we're going to focus on sphere C. So we, of course, need to find the net force, which is going to be made up of the charge that A has on C and then the charge of the force that B has on C. So A is going to be the force of A on C, which is equal to K times QA times QC, all divided by the radius or the distance between the two squared. Recall that K is Coulomb's constant, and that has a value of 9.0 times 10 to the 9, and the units on Coulomb's constant are Newton meters squared per Coulomb squared. The charge of A is given in our question, 4 times 10 to the negative 6 coulombs, and the charge of C also given in the question, 6.4 times 10 to the negative 6 coulombs, all divided by the distance between the two of them, which is 30 centimeters or 0.30 meters, all squared. This leaves us with a value of 2.6 newtons, and since it's positive, we're going to say that that's going to the right. We're going to do the same thing with FBC, so following the exact same procedure, except instead of QA, we have QB. And this is going to give us a value of negative 1.4 newtons right, or 1.4 newtons to the left. To find the net force on C, we're looking at the sum of all the forces on C, which is the force of A on C plus the force of B on C. So that's 2.6 newtons plus negative 1.4 newtons. That leaves us with a net force of 1.2 newtons, and since that's a positive value, it is to the right.